Alright, there's kind of a slick way of graphing linear functions, linear equations. And what it's based on is you only need 2 points on a line to graph a line. You know, you just connect the 2 points and that's your straight line. So there's two special points that a linear function will have when it's graphed, and those are called the x and y intercepts. So here's just a random line I drew on this coordinate plane, and I'm highlighting its y-intercept and its x-intercept. So the y-intercept of a line is the value of y at which it crosses the y-axis. So this is the y-axis. Maybe I should label that y-axis. You always have the y-axis going up and down. It's the vertical axis, and then this is the x-axis, the horizontal axis. So the value of y when the line crosses the y-axis. So here it's 1, 2, 3. So the y-intercept would be 3. The value of y is 3 when it crosses the y-axis. X-intercept is the value of x when the line crosses the x-axis. So here the line is crossing right at this point, and so that's x is 1, 2, 3, 4. So the x-intercept would be 4. That's the value of x when the line crosses through the x-axis. So so you can find these 2 points for any linear function, and then plot them, and then connect them with a line, and then you've graphed a line. So it's kind of a cool thing, right? So but okay, in order to do that though, we need to notice two things. So for the y-intercept, what's the value of x when the line crosses the y-axis? Well, the value of x, the value of x right here when y is 3 is 0. Similarly, what is the value of y at the x-intercept? So when the line crosses through the x-axis, what is the value of y? Well, value of y is 0. You know, it's like that, right? So, so to find the y-intercept of a line, we would set x equal to 0, and to find the x-intercept of a line, we set y to 0. Okay, so let's do a couple of examples. Here I've got the equation for a line, and it's in the standard form. Okay, so I'm going to find the y-intercept. It's the value of y when the line crosses through the y-axis, and I'm going to find the x-intercept, and I'm going to plot both of them on the coordinate plane, and I'll connect them, and then I've graphed this line. So at the y-intercept, x is 0. X is 0. So what I'm going to do is I'm going to set x to 0 and solve. So I'm plugging in 0 for x. So yeah. So I've got 5 times 0 is 0. That's gone. So then all I'm left with is 2y equals 10. So y equals 5. So when x is 0, y is 5, which means that the y-intercept is 5. You know, I just divide both sides by 2, right, to get y by itself. Alright, now what's the x-intercept? Well, at the x-intercept, the value of y is 0, so I'm just going to plug in 0 for y. So I've got 5, so my equation becomes 5x plus 2 times 0 equals 10. This is gone, so I've got 5x equals 10. So x is 2, right? Divide by 5. 5 times what is 10? 2. Okay? So now I can plot these guys. Let's see. Oh, I wanted my cool. Anyway, I'll plot it with these awesome explosion things. It's like intercepting kind of. All right. So the y-intercept is 5. So actually, let me just move everything. Let's just get it out of here. Let's make some room. Okay, so my y-intercept is 5. So the place at which it crosses the y-axis is 1, 2, 3, 4, 5. The x-intercept is 2. So it crosses at 1, 2. Alright, then I just connect the lines. And then keep going, the line goes on forever. So draw it past the points but connect the 2 points. Like something like that, maybe. Put some arrows on the end so you show that it's going on forever. Well, that's not. Let's do it like that. Okay. Yeah. So let's try another one. We'll try another one. This time we'll take an equation in the slope-intercept form. It's really easy to do with the standard form. But say like you're given a line in the slope-intercept form. That's pretty common. So okay. So I want to find the y-intercept. I want a new color when I do this. No, 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 no. The y-intercept, and I want to know the x-intercept. Okay, so at the y-intercept, the value of x will be 0. Um, so to solve for the y-intercept first, I will plug in 0 for x, so this will be 4 times 0, which is just 0, it's gone. It's 5, right? Y equals 5. Now, you knew that already because the slope-intercept form is set up so that this is the y-intercept. Okay, but now let's look at the x-intercept. The x-intercept, at the x-intercept, the value of y will be 0. So we'll set y to 0, and we'll solve for x. So to get x by itself, we first need to get this 5 over on the other side. Negative 5 equals 4x. Now I can divide by 4 to get x by itself. So x is negative 5/4, which is equivalent to negative 1 and 1/4. 4 goes into 5 one time, then you've got 1 left over. So negative 1 and 1/4, also known as negative 1.25. So let me plot these. So the y-intercept is 5. 1, 2, 3, 4. Oh, is that the same point? Wow. I guess I'm not very original in my thinking here. Let's just, okay, I'm going to eliminate this graph, sorry. So the y-intercept is 5. 1, 2, 3, 4, 5. And then the x-intercept is negative 1.25. So this would be negative 1, so negative 1.25. Something like that. You can be more precise, especially if you don't draw the point as an explosion. You just draw it as a dot like a normal person would do. That's not connecting them, so I will move that line. So let's make that green, I suppose. So you would connect your intercepts and keep going a little bit. Something like that. Something like that. So so your x-intercept is where the line crosses through the x-axis, and when it does so, the value of y will be 0. So you can plug in 0 for y and solve for x. Your y-intercept is the value of y when the line crosses through the y-axis, and the value of x at that point will be 0. So you can plug in 0 for x and solve for y. Then plot the 2 points, connect them with the line. Boom, done.